Welcome to this third module and our third installment of a conversation. And here we're going to be looking at how do I get renewables on-site or off-site, but with the intention of actually owning the asset. It's a unique way to play it, and there's really no getting around the need to understand the principles of investment decision-making if that business case is going to be made. So in this conversation, we'll be looking at what are those basic principles? How do we articulate the economic case and understand the dynamics of financing that in a way that becomes satisfactory to investment committees, senior management, or whoever really is the recipient of the proposal. So we're going to talk about really two things in basic, and I hope we won't bore you with this, but I think that there's a lot of misunderstanding about these two main metrics that we use, which is the net present value and the internal rate of return. So let's take them one at a time. Net present value has been around for a really long time, and it's seemingly the most standard way to make an investment decision. The basic investment rule is if the NPV of a project is deemed to be higher than zero, we would accept that project, and if it's lower, we would reject it. But that only tells part of the story, and what really matters are the cash flows that we forecast from the project and the discount rate that is used. So the basic process that we teach in any corporate finance class in any business school around the world is I've got essentially three steps. Estimate the project cash flows, determine the appropriate discount rate, and choose amongst projects, selecting by those that have the highest net present value. Now, while forecasting cash flows is relatively straightforward, it really comes down to forecasting whatever prices or inflation, whatever the real drivers are of both revenues and expenditures over time. Where it really gets tricky is around the discount rate. How do we represent this crucial variable by which all of those cash flows, both positive and negative, are brought back to the present day? So we change the language slightly in order to help us with the problem. It's no longer about the discount rate, but about the weighted average cost of capital. And that's comprised of two things. One is the rate of return on debt, and the second is the rate of return on equity. And we know that for any given project, the rate of return on equity is always going to be higher than the rate of return on debt. And why is that? Well, there's a very simple insight that comes from what happens in bankruptcy. In bankruptcy, bondholders are typically the first in line to receive residual payments out of bankruptcy. Shareholders are usually last in line. And that simple ordering of preferences drives everything in terms of risk. So this thing, the weighted average cost of capital, or the WACC, is what becomes the true discount rate, the opportunity cost of the capital that would be employed in the project, and the key barometer by how risk is measured and return is compensated. Now, for many people, that may be a very simple number that comes on high from the corporate financial officer of the company. In other organizations, that will need to be calculated in a bottom-up way based upon the exact risks that are presented by the project.
So Charlie, there's this concept of a project WACC and a company WACC, and these are not necessarily the same. Sometimes project is higher, sometimes project is lower in terms of WACC. So why is that? Because conceptually, as a company, if I know that my WACC is X%, that's the cost of opportunity of the other projects that a company might pursue. So why would a project have a lower WACC? Or sometimes even a higher WACC?
The idea there is that every project presents a different level of risk, and every return should be compensated for it. Now, when you're a diversified company or a large firm undertaking a lot of projects which are generically similar, there could be a good argument. There's no reason to undertake all that homework. It's a lot of extra effort to go about calculating WACCs for each project. But let me give you an example. Imagine you're a large oil and gas company, and you're looking at, say, your first investment in renewables. The question that'll be immediately asked is, are these projects similar to the ones that we do? And it might be that we actually, as a firm, undertake very risky offshore projects in countries with enormous country risk. So does it really make sense to apply that higher threshold to a project which maybe presents a lot less? You can think of examples completely the other way around. Should a diversified utility, maybe in the US, who has a very low WACC, be then employing that capital into, say, high-risk venture capital style projects? Clearly, were they to do that over the long term, things would go upside down. So the idea is that at some level you can get away with that for a while, so long as the average bundle of projects reflects the average risk that's been articulated to shareholders and to bondholders. But a more disciplined sense of capital budgeting would say that each and every project should at least be monitoring and tracking what that rate is, even if it's not always firmly applied.
Fair enough. So if I'm a corporate and I have a WACC of X%, and I'm considering two investments, maybe two projects. One of them is to, do a very safe investment. I'm gonna have a WACC that's lower than my company WACC. And if the next project is maybe putting the money on a horse, in horse racing, then I would have a very high WACC.
Well, you can imagine there wouldn't be so many shareholders happy if we were raising money on the capital markets and putting it into horse racing. But I think the analogy is perfect. There has to be some amount of accountability, and what this thing about project WACCs ultimately drives us towards that sense of accountability in the way that we see what the appropriate rate of return should be. And it's not just the overall level of risk in the project that matters. There's another reason that WACC can change, and that has to do with capital structure. Some projects inherently are more suitable for higher levels of debt. So again, take the example of an oil company. Most oil companies are not highly leveraged. They can't afford to be because the volatility of the oil price means that were they to find themselves in a very low price environment, they wouldn't be able to service the demands of bondholders. Look the other way, a renewable energy project typically has almost no price volatility. Sun is known, the conditions of capital expenditure are pretty well set, and operating expenditure is quite low. So in these cases, with the right policy environment, operators have been able to put enormous amounts of debt into projects. So in this case, the WACC will shift towards one that is more representative of the cost of debt than it is of the cost of equity. The second variable that we tend to use to evaluate investment attractiveness is the internal rate of return. And really, this is just the flip side of NPV, because the internal rate of return is really just the discount rate that sets the NPV to zero. Now, that might not make sense the first time, so let me explain it again. IRR can be both an input to a model, that is the discount rate or the WACC, but it can also be an output from the model. Sometimes we like to use IRR because it's a kind of a clear way of making a direct comparison between forms of investments. So I know that if I put money in a bank account, the IRR on doing that is maybe 1% these days in Europe and North America, whereas putting it into a wind farm might be 6 or 7%. The same comparison can be made in India. What can I earn on government bonds, relatively risk-free investments, and what do I get if I move it up the stack a little by little? So IRR is helpful in that way because it's a single rate that's somehow analogous to investments we understand, putting money into a bank and earning a rate of deposit. That same logic can be used now in corporate investments. And the decision rule is as follows. I'm going to accept projects where the IRR from the project is higher than the minimum IRR that I require. That minimum IRR goes right back to the WACC. So the decision rule there, accept projects with IRRs greater than the WACC. And conversely, reject projects where the IRR is lower than the WACC.